So in this problem, we're asked to graph a cosecant function. Hopefully you know that the cosecant is the reciprocal of the sine. So it might be really handy if we were to first sketch the graph of the similar function, but in sine. So if we were to graph 3 sines of x over 2, that would give us some important points for the cosecant graph. Since the amplitudes are the same, the amplitude is going to be 3, and we can find the period. Also, it has no phase shift and no vertical shift. There's no plus or minuses or parentheses in this problem at all, so there's no phase or vertical shifting. We just have to find the period. So the period is equal to 2 pi divided by this number, in that case 1/2, because x over 2 is 1/2. So this has a period of 4 pi when you multiply by the reciprocal. So this is a stretched out graph, a little bit farther away than what it normally is. So let's label this. Label our axes. So every 2 we're going to call pi. There's 1 pi. Here's 2 pi. We'll call this 3 pi. And then this last one will be 4 pi. Okay, it does not really matter how you label it as long as you get in all the information that you need. Here's negative pi, and here's negative 2 pi. Labeling your graph. So we're graphing sine, which means the sine has a 0 at the origin, a 0 at the end, and a 0 in the middle. Okay, this is true for all sine graphs. They start at the origin, and they finish at the origin, and they have a 0 in the middle. And since it has a amplitude of 3, the maximum in between is at 3, and the minimum in between the next one are also at 3. So then this one will be a maximum, another minimum down there. So we can, let me use my highlighter, a little bit smaller maybe. Here is the highlighted graph for 3 sines of x over 2. Okay, since this isn't really part of our graph, this is just supposed to be here to help us. So for cosecant, cosecant has an asymptote because cosecant is 1 over sine. Anywhere sine is 0, cosecant will have an asymptote. So let's see. Here's a 0 through negative 2 pi, so there's an asymptote. Here's a 0 through the origin. Here's a 0 through positive 2 pi. And here's a 0 through positive 4 pi. Okay, everywhere sine has a 0, cosecant is undefined. It's 1 over the sine value, so 1 over 0 is undefined. And we have asymptotes at undefined values. So now that we have our asymptotes and our maxes and our mins, we can make a nice graph of the cosecant function. Okay, wherever the sine has a minimum, cosecant has a max and graphs to things that look like parabolas. Wherever cosecant has a max, or rather sine has a max, cosecant has a minimum and will graph to things that look like parabolas. And they approach your asymptotes to the left and to the right. And now if you want to, we can go back and erase all of the, maybe we can't erase them. Go back and erase all the other stuff. Okay, we can erase our sine graph, only if you want to make it look absolutely beautiful and let your teacher think that you actually did this without any help. There you go.